Hello, sir. Disha, sir. We will start the session now. I will give a brief introduction about you, and I will then I will hand over the session, sir.
Yes, sir. Okay.
So, hello, participants. A very warm welcome to the another session, that is session number 13 of AICT Training and Learning Academy sponsored 5 days national level online FDP on revolution and advances in e-vehicle. This session is about charging stations and wireless chargers. And this session will be delivered by Dr. S.V. Dishore, Head and Associate Professor, Department of Electrical Engineering, Rajdhani Institute of Engineering and Technology, Kerala. I want to give a very brief introduction about S.V. Dishore, sir. Dr. S.V. Dishore is the recipient of prestigious Dr. Muhammad Harunur Rashid Award from Oklahoma State University, Stillwater, USA. He obtained his PhD degree in electrical engineering from Anna University, Chennai. His current research focuses on deep learning algorithms for forecasting, fault diagnostic systems for modular inverters, solar energy conversion systems, and smart grids. He has 9 years of academic and research experience. He has published several technical papers in international and national journals, and he has guided 14 graduate and postgraduate projects. He is a member in prestigious positions in various national and international forums. He has been an invited speaker in several programs covering 5 Indian states. He has organized 7 events, including faculty development programs, workshops, and seminars. He completed his graduate program in electrical and electronics engineering from Jawaharlal Nehru Technological University and his postgraduate program from Jawaharlal Nehru Technological University, India. Presently, he is working as an associate professor in the Department of Electrical and Electronics Engineering, Rajdhani Institute of Engineering and Technology, and also doing research work in deep learning algorithms, smart healthcare systems, smart grids, solar PV, and power quality improvement techniques. He has authored the following books in his area of interest: Automotive, Electrical and Electronic Systems, Lakshmi Publications; Modern Power Converters, Lakshmi Publications; SMPS and UPS, Lakshmi Publications; Control of Electrical Drives and Power System Stability, all are published by Lakshmi Publications. We are very happy that Dishore sir has accepted our invitation to be a part of this FDP, and they are present here for delivering the lecture session on our Atal FDP. I give warm welcome to S.V. Dishore sir on behalf of our institution and on behalf of all participants to this Atal FDP. So I welcome you, sir, once again this FDP, and with this one I will close my brief introduction, and I will now from onwards the session will be yours, sir. Thank you.
Thank you, sir. Thank you, Kumar sir, for introducing me to the participants. Yes, sir. Sir, are you able to see my presentation?
Yes, sir. It's visible, sir.
Visible. Fine. So today, today's concept is regarding the charging stations and wireless chargers. Here, at first, we will be seeing the revolution regarding how electric vehicles came into existence. Then we will be seeing the requirements, what are the components required in designing an electric vehicle, and then we will be going to the chargers, what are the different chargers we are using, and what are the requirements of a charging station, and then we'll be discussing one more concept, that is, if time permits, we will see the vehicle to grid concept also. So these are the topics to be covered. As I said, here first we will see the history of electric vehicles. Then what are the parts in the electric vehicles? What are the different types of electric vehicles? Then what are the different components which can be modified and which we can use as our research work or the tentative proposal in this EV topic, those who are doing their PhDs. Then we are going to see about the heart of the system. When electric vehicle comes into existence, the heart of the system is nothing but the battery. So we will see what are the types of batteries used in electric vehicles, and how far the charging has been done in the battery. And we will see about the lead acid battery, then the nickel metahydrate batteries, then nickel cadmium, and then we will be going to see the lithium ion batteries. Okay. Then we will see what are the things we have to modify so that fast charging can be done for the vehicle. Uh, then we are going to see the charging stations. So if you want to implement a charging stations, what are the government rules which have to be followed for implementing a charging station? Then the research issues, what are the topics in which we can do the research pertaining to electric vehicles. Then we will see some of the prototype models and the conclusion. So presently here we are seeing about the electric vehicle. Electric vehicle, anybody knows, everyone knows about electric vehicle. The electric vehicle means it will run with respect to battery. That is the
Dishar sir, voice is not coming.
sir. I'm audible now, sir.
Yes sir, yes sir.
Sir. So, is my screen visible, sir?
Yes sir.
Okay, okay. So this is the textbook what I have authored regarding this electric vehicle. So here this textbook contains contains the electrical components what are present inside an automobile or a car, and what are the interior lighting systems, exterior lighting systems, then how wiring has been done inside. And here we are using a small amount of battery, and that battery can be charged by using what is that a generator. And we will be talking about the cutout relay starter motor, and the advanced things means keyless entry system, anti-theft system, seat belt system, then how airbag is coming out, and all these things are being explained in this book clearly, and this is for the Anna University students I have made. And these are the prototypes what I have developed. So this prototype in the year of say in the year of 2014. So 2014, I have developed this solar bike, and we named this as Helios. So it can run at that time. It can run only 30 kilometers. 30 kilometers for one complete charge, and it uses one, two, three, four solar panels. Actually, it, it got some prizes also, and this is another development what I have developed in 2016. So this is a hybridized car. Okay, we named it as Rana, and this hybridized car consists of both the battery as well as it will be running with respect to the what is that? Yeah, fuel also. Petrol as well, petrol-based car, fuel-based car, as well as the battery-operated vehicle.
I'll be sure in it.
So, so here, coming to our right to the topic. If you see the World Economic Forum, okay, two countries, that is US and China, they are first in the race of either manufacturing the electric vehicle and as well as the deployment of electric vehicle. So India has also just started the manufacture, and so many other brands of electric vehicles nowadays we are seeing because of the very high price of our fuel. So why these two countries are in the race, are number one in the race? Why? Because here you can see these countries, in these countries, they will offer subsidies and they will give incentives if you encourage the green energy rather than the use of this fuel-based systems. So for that purpose only, what is happening here is that these countries, so-called as the developed countries, are number one in the race, as well as we have started the thing. So now here is like we are seeing the electric car range per price comparison. So if you see this slide, starting from the Tesla model. So this is the Tesla Model 3 car. Okay, so its range is it can run 264 miles for one complete charge. So 424 kilometers, and the rate of this vehicle is about 42,900 US dollars. So if you are just multiplying with some 76 rupees to 80 rupees, it will be converted to INR. And if you are converting it, it will be just 50 lakhs to 60 lakhs or 70 lakhs. So now, a typical Indian mentality, what we will see that at first, the price of the car, if it is 50 lakhs, then what we will think? We will think that if 50 lakhs is there, I can buy a building, or I can buy a land, or I can buy gold. So price is one of the major issue regarding the electric vehicle. The second issue is that roads, the roads where we drive the vehicle. So in city, one type of driving is there, and in highway, another type of driving is there. So in city, mostly if you are running an automobile if you are running a car, mostly we will use the first, second, and third gear only. So because of the heavy population and more number of vehicles, so there we will think that whether this electric car is suitable for our roads. The second place is the highway type of driving, where you can see in highway type of driving you can see less number of vehicles, but the road is also a straight, and it is also well maintained. So we will think there is it okay for our electric car to be implemented. Now, the third thing comes the charging station. So if we are owning a electric car, then we have to see whether charging stations are available as like our fuel stations. Is it available? Or if I am buying the electric car and after some 30 kilometers there is one charging station, then daily I have to visit that charging station, and I have to swap the battery, or I have to charge the battery, and then I have to come here. So that is a very big issue regarding the implementation of electric car. And then the major thing is that we all will have a thinking that whether this electric car can be used in hill stations, whether the energy used in the battery of the electric car is capable of climbing the hilltop. Okay, so that like that we'll be having a thinking, and we'll be thinking it as an issue in owning a electric car. Then the last thing is that we have to see whether proper service centers are there if there is any malfunctioning of our vehicle. So these are the key issues what we are considering in our place, in our country, regarding the implementation of electric cars. So here you can see an electric car consists of an electric motor, and this electric motor will be run by either DC or AC supply, and for that we are having the batteries, and we are having a plug so that we can charge these batteries. So definitely it will be a DC motor here in this diagram. So now we will see what is an actual vehicle. First, we are having different types of cars. Nowadays, we are using the IC engine based cars. So, steam cars are there, internal combustion engine based cars are there, then electric cars are there. So, if you see the steam cars, who invented steam? James Watt. So, because of him only the steam engine came into existence. So there what happens, the water will be heated and it will be converted to steam, and with that steam engine will be running, and that's how the vehicle will be moving. Then comes the internal combustion engine, that what we are using nowadays so from years. So what are the disadvantages? The disadvantage is it causes pollution, it is noisy in nature, and it is very difficult to start. So actually in the internal combustion engine, carbon oxide, nitrogen oxide, sulfur oxide, harmful gases will be coming out and it will be polluting the atmosphere. So as an alternative, we will be thinking of the electric cars. So electric cars are also having issues. So what is the issue? The issue what I faced when I developed the electric bike in the year 2014. That is short driving range. So that vehicle only runs for 30 kilometers for a complete charge. So for 15 kilometers I can go and I can come back. So that was the criteria in which it was designed. Then the poor battery performance. We do not know the state of charge of the battery, state of health of the battery. So when the battery will malfunction. So these are the constraints regarding your electric cars. You can see here steam cars. So they were existed up to the year 1920. Then came the IC engine based cars. So IC engine based cars now also we are using. Then we are having the electric cars. So electric cars, first the concept was developed in 1800s, from 1830s. Then up to 1925 they were existed. After that, the craze in electric cars has gone down. So because of these disadvantages, okay. Then again, now in the year 1990s, the electric cars have been again they have come back. So these are the different types of electric vehicles. So definitions. So if you call an electric vehicle which uses only electric motor for starting, not only for starting, for driving purpose also. Then battery electric vehicle. So the electric vehicle which uses battery, it is called as a battery powered electric vehicle. Then you are having the hybrid electric vehicle which uses both the IC engine as well as the battery. So from the battery it is connected to the motor, and for motor is used for the transmission purpose. Then you are having the plug-in vehicle. So plug-in vehicle, here you are using from the grid, you can take the power and you can charge the battery, and when the vehicle is not in use, directly from this plug-in cord you can give the power to the grid. So this is the use of a plug-in vehicle, and these are some of the examples of your electric vehicle which are available. The Chevrolet Volt, Mitsubishi electric vehicle. Okay. Then here we are seeing what are the benefits of driving electric vehicle. So when we see, actually the fact is that you can save 70% of fuel cost. Means you can save the money. So one calculation is there that we will be seeing in the next slides. So here you can save the fuel cost, because today, right now in Kerala, the fuel price for 1 liter petrol, the rate is some 103 to 104 rupees, and diesel it is 94.3 paise. So if you are if you are shifting to electric vehicle, there you can save the fuel cost. Okay. Then if you are using electric vehicle, there is 0% of emission is there. So carbon emission, all the harmful poisonous gases evolved from the IC engine will be stopped, so pollution free. Then what is that? The dependency on oil for the what is that? Arab countries, if you are dependent, so this dependency can be reduced by using the electric vehicle. Then you have to enjoy the ride. And nowadays, see, one disadvantage of electric vehicle is that sound won't come. So for that also they have developed such that when the vehicle is moving, automatically a sound has been introduced. Okay. So why actually we need an electric vehicle? See, we know that now everything we are transforming from the conventional energy sources to non-conventional energy sources. We are just traveling from the renewable to from non-renewable to renewable, where we are using the solar rays. From there you are getting the green energy. So solar photovoltaic panel will convert that what is the solar rays into energy. So if 80% of power produced using thermal power plant causes pollution, then we are directly transforming that 80%. That means we are just making that percentage to less. And by 2050, we will be in a condition that some 60% of the electrical energy will be produced by using the wind and solar, and the 40% will be contributing by our hydroelectric power station, as well as thermal power station and a nuclear power station. So this global warming is caused because of the emission of harmful gases, and these gases some amount of gases are being evolved from our IC engines. From factories we will get the major percentage, and some amount of percentage we will be getting from our vehicles. Then if you are using the fossil fuel, then the energy cost is more. Okay, 50 to 60% of oil consumption by transportation sector. So based on these factors, we are going for the electric vehicle, because if things are going like this, tomorrow there won't be any human race. Why? Because everywhere degradation because of this pollution, and climatic changes are happening, and when climatic changes are happening, automatically the food production is less, and if we think of the future, it is very difficult. So only we are now transforming to the renewable use of renewable energy sources. Then the environmental concerns, what I told before, the emission of these gases will what is that, spoil the atmosphere, and it causes air pollution. And you can see, if these types of gases are mixed in the clouds, there will be a cause of acid rains. And if acid rains are falling, what happens? If we are just coming in contact with the acid rains, automatically we will get skin cancer, and the soil fertility will be lost. Okay, so these are the things what happens when we are using the conventional way, conventional energy source. So the conventional vehicles, comparison with conventional vehicles, we see The electric vehicle is highly efficient since it uses electric motor rather than the heat engine. Then this electric vehicle uses the concept of regenerative braking, where you can regain the 30% of energy used during the braking. Then we are going for the hybrid electric vehicle, which is environmental friendly. Okay, and the use of hybrid electric vehicle is that, just I told, if I am carrying my electric vehicle to Ooty, Kodaikanal or any hill station, if I am coming if I am getting an issue that my car is not able to go to the top of the hill with so much of load, at that time the conventional engine, that IC engine, helps in giving that torque to the vehicle. Then, so these are the different kinds of electric vehicles what we are seeing nowadays. So locomotives are run. The pantograph touches the DC bus line. From that, you are getting the power. Then in golf course, you are using the golf carts. These are also made up of. This is also an electric vehicle. Then forklifts. So these are all used in the industries to lift the weights. So shift the materials also. So these are also battery operated vehicle, and this is a bus. Okay, so this is also in the pantograph like structure, where it is the charging mode, and the nuclear submarines. These also runs with respect to the electric system, and the elevators. Okay, and these are different kinds of cars which they use uh, for electric vehicles. So now, as we know, our FDP is regarding the what is that the history, the revolution. Okay, so now we will be seeing the history of electric vehicles. If we consider the history of electric vehicles, somewhere in the year 1830 and 1839, okay, so all over the world we will see what is the history happening. So this history has happened in British. So this British inventor, Robert Anderson, what he has invented a crude electric carriage. Okay. So later, what happened? An American, he is Thomas Davenport. So what he has done, he has first built the practical electric vehicle. So what he has developed? He has developed a small locomotive, a small locomotive train's engine in 1835. That too, that engine will run with regarding the electric power. Then in 1840, a patent has been granted for the scientists in England. So you can see here what they have did. They have introduced, they have made the rails of the locomotive. In railway station we will see the rails. So these rails they have used as the positive and negative negative terminals by providing the DC supply. So for this they have given the patent. And then when electric vehicle comes into picture, we will be talking about the battery, because battery is very, very important. So this Gaston Planck, he is a French physicist, so he invented the lead acid battery in 1859. Then later, this Camille Alphonse Ford, what he has done some modifications to the battery, and he has improved the design in 1881. So this modification, actually I believe in a perfect modification. Why? Because you can see in the good to olden days, some 15 to 20 years back, you can see the fluorescent lamp. The fluorescent lamp will have a choke and a starter, and the size of the fluorescent lamp will be very big, and and the size is very big. But with the advancement, with the improvised version, first the choke was removed and chokeless fluorescent lamp came into existence. Then automatically the starter was removed and only the fluorescent lamp came into picture, and the size of the fluorescent lamp, the thickness of the fluorescent lamp was reduced, but it is giving a good type of luminance. That means it is giving a good lighting. Then after that, the advancement of fluorescent lamp, the CFL lamp came into picture, and after that now LEDs are ruling. So this is how the modification has been done. One person has filed the patent, and the disadvantages in these things have been brought into picture, and every piece is an upgradation and it is a durable piece. So like that, further moving to the history, this English inventor, Thomas Parker, okay, so he is the person who has electrified the London Underground. So what he has done, he has built the first electric car in London in 1884. So that is what you are seeing here. This picture shows the first developed electric car in London in 1880. Okay. The first practical electric car. So in Germany, the first practical electric car was built, and here you can see the first practical electric car. So it was built by an engineer, Andreas Flocker, in 1888. Then, so this was developed in Germany. Meantime, in 1890 to 91, William Morrison, okay, so he developed the first electric car in United States. Now, you can see what is the golden age. So, here you can see there is a great interest. People in those times showed more interest in electric vehicles during the 1890s and the 1900s. So, in order to overcome the operating range of these electric vehicles, what happened? This lack of recharging infrastructure and exchangeable battery service was proposed as early as 1890s. So again, the extension of golden age, you can see here the electrification was done. Electrification was done for charging the electric vehicles. So the acceptance of electric cars was initially hampered by a lack of power infrastructure. So what happened, because if so many people had showed their craze on electric vehicles and bought them, but proper electrification was not there at that time. So these electric poles were laid during that time, okay, for making the vehicles to charge. So the sales of electric cars peaked in the year 1910s. So after that, what happened? See what happened? The worldwide they discovered larger petroleum reserves. Okay, when we are having abundant availability of this fuel like petrol and diesel, automatically the fuel rate will be very cheaper. So when the fuel rate is very cheaper, most of the people will afford the IC engine. Why? Because at that time, what happened? The electric vehicle is performing well, but it has some drawbacks like poor battery. Then it can be used. It can be used for only short distances. Then what happened? This guy, gasoline cars became very easier to operate. Why? Because he has invented the electric starter. Before that, what happens? At the front of the car, only one rod will be there that we have to rotate it. We have to rotate it continuously so that it will start. So that type of assembly has been removed. And in the IC engine car, this Charles Kettering, he invented the electric starter so that automatically, just by using the ignition key, the vehicle will start. So with this, what happens? The decline of electric vehicle has come. So this Henry Ford, what he has done, he has produced a bulk amount of IC cars, and those came into picture. And in the 1910s, completely the electric vehicles have gone down. So these are the different places where the invention regarding the electric vehicle has taken place. Okay, so these things we have seen in the previous slides. So this is known as the Great Electric Car Race. So in 1968, what happened? From the Massachusetts Institute of Technology to Caltech, okay, there was an electric car race in 1968. So in between Massachusetts Institute of Technology and Caltech, there were 53 charging stations which are spaced 60 miles apart. And one more thing is that the cars, electric vehicles which are developed by Massachusetts Institute of Technology used nickel cadmium batteries, and those the amount was $20,000, whereas the Caltech used those batteries which are having the cost of $600. Then after that, in 1970s and 1980s, again the oil crisis came. So again the boom on electric vehicles came into existence. So after that, again there was another car race in 1970 that is called as the Clean Air Car Race. Okay, so in that around 50 plus cars have raced from Massachusetts Institute of Technology to Caltech. They used alternative powertrains. Okay, the cars which are developed in the Caltech, they use the concept of regenerative braking. Okay, and the cars which are developed by the Boston Club, they use the concept of battery swapping. Then the cars which have been developed in the Toronto University, they use the concept of parallel hybrid design. So which is very similar to one of the car Prius architecture. Then the cars in the Massachusetts Institute of Technology use a series hybrid and electrically commutated motor. So these were the advancement in those stages, 1970s. Then after that, the early 1990, okay, so this is one more, the California Air Resource Board. Okay, so it told about the Clean Air Agency. Yeah, so we have to control the pollution, the fuel emission, harmful gases. So we have to just convert all the vehicles to electric vehicles. Then due to some of the drawbacks in the electric vehicle, hybrid electric vehicles came into existence, which is a combination of both the oil-based, that oil means the fuel-based system as well as the battery-based system. And this is your modern highway capable car. Okay, so this was developed in 2004 and it was delivered in the year 2008. Okay, so this was developed by Tesla Motors in California. Okay, then this is also the Mitsubishi. Okay, so it was launched in Japan. Okay, it was launched in July 2009 and customers got it in 2010. Okay, so it can travel up to 40 miles, that means 64 kilometers on battery power. And after that, it can be run using the IC engine. Okay, so now we are going to see about the dynamics of electric vehicle. So when we see the dynamics of electric vehicle, okay, you can see a car is moving on an inclined plane. An inclined plane, it makes an inclined angle theta. So here you are having two types of force acting on the car. One is the propulsive force and another one is the repulsive force. You can see the two types of force. So this is one type of force and this is another type of force. That means the arrow what it is showing. So here you can see the dynamics are the total force balance can be given by the formula M alpha is equals to Ft minus sigma of Fr. So where Ft is nothing but the total force. Okay, total force, that is total propulsive force. and this is the total repulsive force. So here the total repulsive force. So this can be got from the previous diagram. So the total repulsive force is nothing but, see what are the arrows which are coming in. You are adding that one. Okay. So which are mg sin theta. Okay. Mg sin theta. Mg sin theta is there. Then mg CRR cos theta. Mg CRR cos theta. Okay. So this is also going towards the car. So like this, you are adding all the equations plus off into rho A CD into B minus BW. So this is the total resistive force and the propulsive force. Total propulsive force means from here, from this formula, you can get the total propulsive force. Ft is nothing but m alpha plus sigma of Fr. So you are adding it's m alpha plus mg CRR cos theta plus off rho A CD to B minus BW whole square plus mg sin theta. So after deriving the force, the repulsive force and propulsive force, you are going to find out the power required to drive the vehicle. So the power required to drive the vehicle, just in this equation you are multiplying with the velocity, because acceleration, nothing but the velocity, rate of change of velocity. So P is equal to Ft into V. So in this equation you are multiplying with the V. Then this is the sample calculation what I have taken. So in this sample calculation, the mass of the vehicle I have taken as 1000 kilograms. The speed of the vehicle as 100 kilometers per hour. So here, based on that, we are substituting, we are taking these parameters. How I have obtained these parameters? These parameters I have obtained from the data sheet of the manufacturer. If you are using a Maruti car, the Maruti 800 car, if you are using the Maruti 800 cars data sheet, you can get these things. Okay, so what is the torque required for the vehicle to move? So substituting these values in this equation, you will be getting the power. Then the power from the acceleration for 0 to 100 kilometers in 10 seconds, you will be substituting in this formula and you will be getting that 38 kilowatt. This K is small letter. Okay, so here also the K is small letter. So total the power required for driving is 69 kilowatts. Now that is the power required for movement of the car. Now we have to know about the range calculation. So how much range our vehicle can be traveling. So if you want to know about the range, what you are going to do is that you are just taking an example of 40 kilowatt hour energy battery what you are using in your electric vehicle. So this 40 kilowatt battery will be fully charged and it is ready to give 40 kilowatt out. So we'll be taking as 20 kilowatt to run the vehicle at 50 kilometers per hour. For 50 kilometers, it will be running at 20 kilowatt. So for another 50 kilometers, you can use another 20 kilowatt. So the battery can release 20 kilowatt power for 2 hours. So it can release this 20 kilowatt for 2 hours. That means this complete battery requires 4 hours to discharge. So the range can be calculated by 50 kilometers into 2, that is 100 kilometers it can just move with this full charge capacity. Now we are coming to the concept of how economical is our vehicle, electric vehicle, than the ICH. If you see here, the conventional vehicle, the average mileage I am taking as 15 kilometers per liter. And now I have put that 1 liter of fuel, either it is diesel or petrol, it is 100 rupees. So when we are calculating, you are getting just 6.6 rupees per kilometer. But whereas our electric vehicle consists of 40 kilowatt battery and it is capable to move up to 120 kilometer range, then 1 kilowatt hour is equal to 8 rupees. So for 320 rupees, it can go for 120 kilometers. So approximately you are spending 2 rupees 6 paise per kilometer. But in the conventional vehicle, you are spending 6 rupees 6 paise per kilometer. So from this you can see that electric vehicle saves our pockets. Then these are the present and upcoming electric vehicles. So Renault, Chevrolet, Hyundai, Nissan, Tesla, Fisker, Audi, then Jaguar, Aston, Mercedes-Benz, next generation Tesla, then Volvo. So these are the various companies uh, which are having the electric cars now. Okay, and these are the popular electric vehicles what we are seeing nowadays. So here, if you see the specification of an individual car with respect to the company, the specifications will change. You can see here this Nissan Leaf. This is an electric car. Okay, the charging can be done from this position. At this position, they will do the charging. So it is having an electric motor, and this electric motor is a synchronous type of motor. Okay, so its rating is 80 kilowatt and 110 HP, and its torque is 280 Newton meter. Okay, so transmission is nothing but the motor will rotate, and that the driving power will have to be transmitted to the wheels. So that is called as the transmission. So here you are using the single speed constant ratio transmission. And very important thing is that an electric vehicle will operate by using the battery. So the latest technology, the lithium-ion battery is best and is highly efficient. So you are using a 24 kilowatt hour lithium-ion battery. Okay, and this is the range. So up to how much kilometer it can run. Then we are using the charging systems. So in a future slide, we will be talking about the charging systems. So the charging systems, okay, it can we are using the what is that, the AC charger as well as the DC charger. So for that you are using the 240 volts AC supply as well as 480 volts DC supply. So this can be charged using the AC charger as well as the DC charger. Okay, then this is another type of car, that is the Ford Focus electric car. Okay, so here from company to company the transmission will differ, the battery capacity will differ, the range will differ, the charging system will differ, and the motor also will differ. Here you are using the synchronous motor, lithium ion battery, and it can run up to 115 miles. Okay, then here you are using the DC fast charging system. Okay, here also the same, the BMW. Here you can see the specifications. Okay, so this is Chevrolet Volt. Okay, so this is an hybrid type system where it is using series hybrid model. So what is the series hybrid model? We will be seeing in the next slides. So electric motor, here you are using the permanent magnet motor. Permanent magnet motor here you are using. So now you will be having a doubt. So if permanent magnet motor is used, okay, and always the motor is rotating, okay, so the magnets, they may be demagnetized. There will be a chance. No such process will happen. Why? Because if a magnet has to be demagnetized, then it needs high temperature. And moreover, you will be having another doubt. The car is always moving. So vibration will be occurring inside the motor, and automatically there will be a chance of demagnetization of the motor due magnets due to friction. This is also not possible because these motors are not loosely fixed. They are completely installed perfectly. Okay. Then here we are using the AC type of charger. This 240 volts, with respect to 240 volts and 120 volts. Okay, and here you can see the range of the vehicle up to 380 miles. It can. These are the different cars which are having the different specifications. And up to now, up to our knowledge now, we know that permanent magnet motors are used as well as the synchronous motors are used for the electric motor for the electric vehicles. Then the battery, you are seeing the lithium-ion battery is used. Then for the charging, we are using the DC type of charging as well as the AC type of charging. And here we are seeing the basic structure of a hybrid vehicle. So if you see the basic structure of hybrid vehicle, here the front part is completely your what is that IC engine, and here completely your what is that battery type of operation is there, the battery operated vehicle. So together, if you are combining these two, will the efficiency will be more, and it can be used to save uh, the environment. Okay, the carbon emission will be lower. Now, here there are three types of vehicles. In these three types of vehicles, you can know what is a conventional vehicle, what is a hybrid vehicle, and what is a battery electric vehicle. So, conventional electric vehicle, just if you are giving the fuel, fuel is given to the engine, and from the engine, what is the engine? Engine is rotated, and it will be coupled to this what is that sun and planetary gears, this assembly, so that the wheel will be rotated and the vehicle will be running. But when we are coming to the battery operated vehicle, okay, instead of fuel, you are using the battery, and from the battery, what is happening here, engine is not there, directly you are putting the motor or generator, and from the battery, the supply the power is given to the motor, and motor or generator will rotate, and from that you are going to the transmission system, and like that your rotation happens. And when we are talking about the hybrid system, combination of both this conventional as well as the electric vehicle combines the hybrid. So here you are using the engine as well as your motor generator set. So when the engine is running with respect to the fuel, this motor will act as a generator, and it will produce the DC power, and it will charge the battery. So like that, we are having the hybrid structure. So in the hybrid structure, we are having the four types. So one is a series hybrid, parallel hybrid, series parallel hybrid. So three types, series parallel hybrid. So here, this picture you can see about the series hybrid system. Okay. So here, why the name came series? Why? Because the power flows to the wheels in series. So a series hybrid system can run a small output engine in the efficient operating region relatively steadily and generate supply electricity to the electric motor and efficiently charge the battery. So what happens here? Here you can see this is the engine. Okay, it is coupled to the generator. Okay, so when starting, the engine makes the generator to rotate, and from the generator you will be getting the DC power. That DC power is given to the inverter, and what an inverter will do, automatically the DC will be converted to AC, and that AC power will be used for running the motor. And this motor here, the gear assembly is fixed. So like that, the movement in the wheels have been done. So that is the first mode, and the second mode is battery operated vehicle. So from the battery directly inverter converts DC to AC, then the motor rotates. So this is a series way, so series connection. Okay. Then the parallel system. In the parallel system here, so at this place, what we are doing, just we are coupling here, and we are removing this connection. So when coupling and removing this connection, you are obtaining a parallel system. See here. So parallel means in any circuit the current is dividing, means we are seeing the parallel. So here also you can see the division. So like that, from the engine, the transmission system is there, and from that it is coupled to the motor or generator. So from the battery again you are giving to the inverter, and that AC power is run by the motor, and the transmission takes place. Or otherwise, from the engine it is given to this transmission purpose, and from this gear it is run. So it can be operated by using the fuel as well as the battery. Then this is your structure of both the series and parallel hybrid system. Okay, so here also the same thing happens. Combination of both the series as well as parallel, it can be operated accordingly. So here you can see. Now you can see how the plug-in hybrid electric vehicle or electric vehicle, how it will work. So this is the general electric vehicle. Okay, hybrid electric vehicle. It consists of combustion engine, electric motor, battery, and fuel. So battery rating is 1 kilowatt. Now what I am doing is that now I am running the vehicle by using the fuel. This is the normal car, operation of the normal car. Now what is happening? This, while it is operating, this electric motor or generator is coupled, okay, and the battery is getting charged. And this battery can be used for the lighting of interior and exterior lighting systems and other components. So this is used in the common car. Then this is how your electric vehicle is operating, hybrid vehicle. So this combustion, it is rotating, and this here dual mode is there. First mode is the gasoline mode, and when gas is finished, automatically it will operate by using the battery. Battery will be giving power to the electric motor, and this is coupled with this front wheel system. So like that, the battery is getting discharged. Then plug-in hybrid electric vehicle, what we are using more number of batteries. Okay, so the battery rating is 5 to 15 kilowatt hour. So now what we are doing, we are giving supply from our house or any charging station. What is happening? Our battery is being charged. Then what is happening? By using this, the battery operated vehicle, it will operate till the battery gets discharged. So after discharging of the battery, now if you are not having, if our charging station is at a larger distance, okay, at that time we can run it with gasoline engine. So for my according to me, if you want to climb the hill by using the hybrid electric vehicle, you can use IC engine, or in the normal roads we can use the battery operated. So these are the things what we have seen. So this is the degrees of hybridization. So what happens with respect to the micro hybrid, mild hybrid, full hybrid, and plug-in hybrid vehicle? So these are the some of the benefits. So the Citroen C3, okay, is a micro hybrid car. So it will have only automatic stop-start engine in stop and go traffic. But all other features will be available in this Chevrolet Volt. So that is a plug-in hybrid vehicle. That is the degrees of hybridization, and you can see here the efficiency line. So this is less efficient, whereas this is more efficient. So these are the different types of electric vehicles what we have seen. There is the plug-in hybrid vehicle, extended range electric vehicle, then battery operated electric vehicle. Already we have discussed all these things. So these are the advantages of plug-in hybrid electric vehicle over the conventional engines. So it encourages the regenerative braking, then the reduction in engine. When engine is removed, the overall weight of the vehicle is reduced, then the fuel efficiency is increased. Okay, so all these points we have discussed. Now what we are going to see is about the energy storage system. Why? Because we are using the motor, and proper power has to be given based on the different types of motors, the DC motors or AC motors. The structure, the architecture is completely different in implementing. So the very essential part in an electric vehicle is your energy storage systems. So these are the different types of energy storage systems. The chemical energy, chemically we are using the hydrogen and synthetic natural gas. Then in electrical we are using the capacitors. Okay. Then in mechanical we are using the flywheel, pumped hydroelectric, pumped heat electric storage, and there are so much things. And in electrochemical we are using the batteries. Okay, in batteries also we are having the more amount of batteries. That is a lead acid battery, lithium ion battery, then lithium polymer battery, lithium sulfur battery, sodium sulfide battery, then nickel cadmium battery. So like this, so much of batteries are there. Then, so what are the desirable attributes? What are the desirable attributes of a storage system? Okay, so it has to supply high peak and pulse specific power. Then high specific energy at pulse power and high charge to maximize the regenerative braking and long life. That the challenges regarding the energy storage system is that the accurate techniques to determine the battery state of charge and develop abuse tolerant batteries and recycle. Now, there will be a concept that, sir, instead of using this, what is that? Instead of using the batteries, we can use the ultra capacitors. No, ultra capacitors are used only to boost the energy level. That's it. So, if at all your electric vehicle has to climb any hill, at that time, the additional boosting of energy can be given by using the ultra capacitors. Okay, so what ultra capacitors will do? It will store charge in a polarized liquid layer between an ionically electrolyte and conducting electrode. So just we have to boost it. For that we are using the ultra capacitors. Then we are using the flywheel. So this flywheel is pollution free. What is that? It contains no acid or hazardous material. Okay, it is not affected by temperature also. It stores the kinetic energy within a spinning wheel. Okay, but it is heavy weight and it is large in nature. Then this is the concept of regenerative braking. So when the driver brakes, the motor becomes a generator and the kinetic energy generates electricity stored in it. So this type of assembly is used in the Toyota Prius car, in which about 30% of heat lost in the kinetic energy from braking. So these are regarding the battery. Okay, so I told there are so many batteries apart from lead acid batteries. They are the nickel metahydride battery. Okay, so these batteries are very costly. Okay, they are very durable, but they are costly, heavy, and bulky. But they are maintenance free, and they release less toxic gases, and they can hold more amount of battery. The state of health of the battery is more. And this is regarding our lead acid battery. What we are using in, today, we are in each and every place we are using a lead acid batteries only in vehicles, not in electric vehicles, in IC vehicles. Then in bikes and everything we are using the lead acid battery. So why we are using, because these are the specifications. Based on these specifications, we are using the lead acid battery. First of all, low cost it is, and it also got a minimum maintenance. Okay, and these are the batteries used in electric vehicles. So most of the electric vehicles use the lithium ion battery. Okay, because it is highly efficient. Okay, then these are the comparisons. These are some of the definitions of battery, and these are the structure, characteristics of the battery, how the lithium ion battery will be running. Okay, and this is the charging cycle. Okay, so in the charging cycle, okay, initially when we are going for putting a charge, if you are taking our mobile phone, suddenly from 0 to 80%, your mobile phone will charge within 1 hour or 1.5 hours. Then after that, it takes some time. From 80 to 100, it takes more time. So that one I have divided into 3 types of stages. One is the bulk stage, absorption stage, and float stage. So the bulk stage, what is happening here, you can see from the graph, the voltage gradually rises. Usually, 12-volt battery if you are taking, the voltage actually rises from 14.4 to 14.6 volt. While you see the current graph, there the batteries draw a maximum current at that point. Now, coming to the absorption stage. the voltage is maintained constant. Here you can see the voltage is maintained constant for some time being. Okay, so we can take for 1 hour the voltage is maintained constant. But at this stage, what is happening? The current is gradually decreasing. That is the absorption stage. So because of this condition only, it is taking much time to charge after the 80% of charge. And then currently gradually tampers off as the battery charge. Then the floating stage, here what we are doing, the voltage is lower. Okay, usually the voltage initially it was 14.4 to 14.6. So that voltage is lower to 13.4 to 13.7 volts. Okay, and here the battery draws a small maintenance current until the next cycle. So this is what is known as charging of the battery. So this is very important, and this science we have to know before we go to develop a charging station. Now we have come to the second part, that means history of the electric vehicles and types of electric vehicles have been finished, and now we are going for the charging systems and charging stations. So in these charging schemes, we are having two types of charging. One is direct charging and indirect charging. So if you think about the direct charging is again divided into plug-in charging and wireless charging. Whereas indirect charging is nothing but battery swap. So these things we will be dealing in detail. Okay. So what are the requirements needed for charging? For charging a battery of an electric vehicle, you need a charging station supply. You need the type of charging, that is the DC charging as well as the AC charging. Then how this charging will be done? By using the converters only, we can give the controlled amount of power to the battery. So power converters are needed. Then you need so much of batteries so that additionally it can be charged and kept, and battery swapping can be taking place. Then you need the plugs, socket outlets, vehicle couplers, and vehicle implants. Here you can see the indirect type of charging, that is called as the battery swapping or fast charging system. You can see a person, what he is doing, he is swapping the battery of a bus, okay, or a bus or van. Okay, what he is doing, automatically these batteries are already charged, and here you can see at this point already the batteries which are discharged will be removed from this slot, and here he is inserting the charged batteries. So this takes certain minutes of time in replacing the battery, and we can do. So this type of charging technique has been encouraged all over the world. Then we are having the two types of chargers. So I told that DC charger and AC charger. So those things we are having here. So one is the onboard charger and off-board charger. So here you can see this is the onboard charger. So what are the things you get in the onboard charger? The onboard charger, you are having a single phase AC supply, and that AC supply is being controlled. That means here our power electronic devices we are using, and from that we are giving it to a connector. The connector also we will see what are the different types of connectors are there. So connector, from the connector what you are doing, we are putting the connector into our vehicle. So from the connector, that supply is given to your charger. So what this charger will do, this charger actually, to my knowledge, it has a rectifier, AC to DC converter. What it will do, this is a DC, this contains DC. So I have to supply DC, but I am supplying here AC. So this AC is converted to DC in this charger, and the DC is given to the battery, and the battery is being charged. Now what is happening? After that, the battery energy is given to the motor controller, and from that signals are given so that the battery's complete energy is given to the motor and it will be operated. This is what we are calling about the onboard charger. And in offboard charger, this charger will be here in this assembly. That means in the connector itself, you will be having the what is that, change of power. So always battery is there means you have to supply DC power. So DC power will be coming when we are putting the charger along with the connector itself. So in the cord itself, in the cord or the connector assembly, we will have a charger where you are converting the AC to DC. So these are known as the onboard chargers. So here you can see the levels of EV charging. So now, up to my knowledge, there are 3 types of chargers: level 1, level 2, level 3. That means level 1 takes few hours for charging the battery. Level 2 takes little hours for charging the battery, and level 3 takes minutes in charging the battery. So there are AC chargers as well as DC chargers, and here you can see that, okay, this is AC level 1 charging. If you are seeing the level 1 charging, here the time taken for charging is 7 hours, and the connector, by using this connector only we can charge the battery. Okay, but for fast charging purpose, that is level 3 type of charging, it takes only 30 minutes. That means high power applications, high power, it is using 120 to 240 kilowatt high power, and for high power applications you are using this type of charge demo. This is one type of connector that is very famous. So DC level 1, level 2, level 3, so there also the voltage levels are being increasing from level 1 to level 3, and here also the current level is also increasing from level 1 to level 3. So as the voltage and currents are increasing, the power also is increased, as well as what is happening here, the time taken for this time taken for the battery to charge is increased. Okay, so these are the some of the benefits and disadvantages of your onboard charger and offboard charger. So, the red color is your disadvantages. Okay, so what are the benefits we see about the onboard charger? So it takes less energy. That means for kilowatt per hour transfer, it takes less energy. Then heating of battery is not taken into consideration when we are going for onboard charger. Then the pilot signal J1172, that is a connector. This connector is used for the onboard charger. But here, when we talk about the onboard charger, the charger setup is present inside the vehicle. So the disadvantage is that the weight of the vehicle is increased, and moreover, it takes more time for charging. So if at all, if you are going to any place, for example, from Kerala, I am coming to Karnataka. So I have to reach there, I have a meeting. So on time I have to reach. And if I am taking an electric vehicle, what is happening? If I am using an onboard charger, it takes so much of time for me to charge the vehicle. And slow charging, what it will result? It results that the place in Karnataka, I cannot reach that concerned place on time. So that is the disadvantage. Then they charge at low power levels, to very low power levels, 20 kilowatt like that. Then onboard rectification is used to manage battery management system. So battery management system is possible. Here size and weight restriction due to EV design. More number of charging components are used. Then recharge at any place within electric outlet. So if any outlet is there we can easily recharge. Here, some of the benefits and challenges of off-board charger are: heat transfer of energy is concerned. So need to address battery heating issues. Why? Because here the charger is within the core. Then weight on EV is removed. Why? Because that what is that inside the vehicle the charger is not there. So no more better battery management system. So no flexibility to recharge at various places. Okay. The power output limitation is concerned within the capability of batteries to accept charge. That is a very, very important criteria. The fast charging is possible, then charge at high power levels. So generally, this level 1, level 2, level 3 type of chargers, I can just divide it into level 1 means we can call it as a overnight charger. That means after doing our work, we will be just taking rest at our home during the night time. So during the night time, if we are charging our electric car, then we can use a level 1 type of charger, that is a slow type of charger. Okay, it takes time. So 220 volts we can use for 22 kilowatt rating. Then level 2 is called as the destination type of charger. So I am telling here about the level 1, level 2, level 3. So level 2 is nothing but a destination type of charger where we can carry the power and we can put it accordingly. Then level 3 type of charger, that is what charger we have to implement in our charging station. Why? Because it consumes very less number of time. Okay. So here we can see a AC charger. What are the things present in an AC charger? See, in an AC charger, okay, what is happening in a charger? Ultimately, here you need to charge a battery. So for charging the battery, what you are doing, you are giving the AC supply. AC is converted to DC, and again from here, DC is converted to again DC. So that is nothing but this is a AC to DC converter or your power factor correction circuit, and here is your LLC resonant converter what you are using by using the high frequency transformer. Okay, so what is the need for implementing a power factor circuit? Why? Because see, whatever the input AC supply what we are giving, okay, we do not know that the voltage and current are in phase. And if capacitors are introduced in the circuit, automatically what happens? The current leads the voltage. So at the time, your power factor will be changing. So the power factor circuit is used to remove the harmonics, okay, and maintain in phase, so that the stabilized power will be given to this LLC converter. And what this LLC converter will do, it is responsible for charging the battery. So first, I will be dealing about the AC charger. So in AC charger, mostly we will be using the Wiener rectifier. So the Wiener rectifier, here you can see this is the AC system, okay, and here the output is a DC system, and here you can see the unidirectional power flow. Here also one can develop a modified Wiener rectifier because this is a bidirectional switch what he has implemented. Single diode with the single switch with 4 diode combination 1, 2, 3, and then the capacitor band is there. So here you can replace it with RG IGBT or common emitter configuration, common collector configuration of IGBTs or MOSFETs, so that you can make the charging system a very, very compact one and weightless. So this is your Wiener rectifier. It is having the unidirectional flow, okay, and here it enables the features of vehicle to grid configuration. This I will tell you later. It is vehicle to grid. And here you are talking about the DC charger, and this is the DC fast charger called as Onboard Charger. Okay, here also you are using what is that input supply is given, then you are giving to the power factor correction circuit where you are removing the harmonics, and you are giving to the isolated DC to DC converter. See, why you are going for the isolated DC to DC converter? You can go for a boost converter, no? Because in isolated DC to DC converter, you are using a high frequency transformer. So in general, then actually the voltage will be like this, and the current, okay, the current what it will do will gradually increase at this point, and it will decrease, and it will increase. So actually here, what happens if you are continuously making the giving power to the battery? What happens? Heating of the battery will be happening. So heating means this happens because of the continuous flow of electrons. There won't be any gap. So if the current is reaching at this position, it is continuous, and after that it is slightly bending. So at this point, the electrons will be a little bit relaxed, and after that again it reaches this one, it reaches the peak. So here the interval is given. So based on that interval can be provided by using this transformer only. So based on that interval only, the heating of the battery can be reduced. So that is the very important concept why we are going for the isolated DC to DC converter. Then here nowadays in this DC fast charging, we are using two types of resonant DC to DC converter. One is the isolated LLC resonant DC to DC converter, and another one is the isolated phase shifted DC to DC converter. So when compared to this isolated, nowadays we are using this isolated LLC resonant converter only, and so much of research is going on in this side. Okay, so what are the importance of this one of isolated LLC resonant DC to DC converter is it is highly efficient in nature. Okay, it enables soft switching techniques, zero voltage switching. So when soft switching is enabled, the electromagnetic interference issue is removed. But a disadvantage is that you can see larger output ripples. The output will have some ripples. For that we are using the capacitors to remove the ripples, and it has a limited output voltage range. As we know, this is the DC fast charging setup, what we have discussed priorly. Okay, so here when we come across the isolated phase shift DC to DC converter, okay, you can see a wide output voltage range. It can be used for a wider output range. So here the disadvantage has been fulfilled here, and the output voltage. See here you can see the L inductor. So you can see the low voltage ripple. Okay, so no need for the electrolytic capacitors. But the only disadvantage is that hard switching is implemented for light load conditions. When hard switching is implemented, automatically the losses in the system is increased, the electromagnetic interference is increased, and the efficiency is lower. Then, so what we are going to do is that, okay, we are going to implement more number of DC chargers. So for more number of chargers, to get the output voltage more at higher levels, what you are using, you are going for the multi-level setup, like multi-level inverters. When you are implementing the multi-level inverters here, what is happening, the switches are more. Okay, the switches are more and the components are more. Okay, and what happens, automatically the losses are increased, and it is a very hard thing to find. So we have implemented the silicon carbide type of semiconductor switches. You can see this is containing so much of sources, so much of transformers, so much of switches. This is also the multi-level setup which is having the so much of switches. Why? Because these are able to withstand only high, are used for only high power applications. The output voltage is more. But with the advancement of silicon carbide type of switches, we can get a greater performance at high voltages. So SiC switches are used here, and the circuit is becoming very simple. Okay, and this is your tank circuit. Okay, and this is your rectifier circuit, and and completely this is your isolation transistors. So now see here what I have implemented is that this is your silicon based LLC converter, silicon of 15 kilowatt, 15 kilowatt 20 amps converter you can see, and this is your silicon carbide 20 kilowatt LLC converter of 35 amps. Current rating is more, power rating is more. You can see by visual inspection, you can see the components present here of this circuit is more compared to this one. Okay. See, this is 600 volt silicon based 15 kilowatt LLC output of 20 amps. But here the rating is more, silicon carbide based 20 kilowatt LLC, which gives an output of 35 amps. So you can see the consideration here, after putting more components, its weight is more, 4.1 kilograms, and its volume is 180 cubic inch. But here, the weight of the system is 3.2 kg, the volume is 68 cubic inches, and 20% we are having fewer parts compared to this one. Okay. And now, when we talk about the switching system of the converter, okay, here the dead time should be kept as short as possible. So this is the dead time. This red color line is your dead time, which has been kept as short as possible. Why? Because to keep the resonant tank circuit small, so that we can choose a smaller values for the tank circuit. The tank circuit I have shown already here. So this is the LR, this is the tank circuit. So for doing this, we need to switch fast to maintain the dead time to the minimum value. So if we look through the resonant current here, this point, okay, through the resonant current through the inductor, it looks very small, and the diodes which are present in the secondary side of the transformer are self-commutating in nature. Then what we will do, the lowest output voltage, what we will do, we will be matching with the resonating frequency. So when we are matching the lowest output voltage with the resonating frequency, then the battery starts charging. So here, this complete setup, this complete waveform is shown for the switching frequency of 200 kilohertz, okay, which is having a voltage gain ratio of 1. Okay, this is for 200 kilohertz. Here we are enabling the soft switching technique, and it is highly efficient. Then what happening? We are putting here the switching frequency is less than the resonating frequency. So when the switching frequency is less than the resonant frequency, you can see the dead time is increasing. More or less, the current flow from the resonant current flowing through the inductor, here it is also small, but the efficiency is decreased. If efficiency is decreased means efficiency is decreased a little bit. This is your charging operation, and here we are seeing the behavior of the system when the switching frequency is less than the resonating frequency. But when the switching frequency is greater than the resonating frequency, automatically, see, your switching frequency is 260 Hertz, automatically hard switching is enabled, losses is increased, efficiency is degraded. So we have to operate either in this mode or in this mode. Then this is one of the online tool, the simulation tool, that is SpeedFit. Okay, so in which we are taking the SIC devices. Okay, and here you can have, these are the options of the DC to DC converter, buck converter, boost converter, and you can see the performance by giving your own parameters, your own input voltage, your own output voltage, your own capacitor value, tank circuit value, switching frequency, and your own rated output. So this is how it will be looking like, and here you can adjust the parameters and you can take the output voltage. Okay, and this is one of the block diagram of your LLC resonant DC to DC converter for high power applications. So in high power applications, you are seeing an additional switch which is connected in parallel. Here you see additional switch is there, and here the control technique is very easy. Constant current and constant voltage control, it is given to the controller, and from that signals are given to the corresponding switches, and based on the switching you will be getting the output voltage. The tank circuit values are LR is for 16 microhenries and CR is 35 nanofarads and LM is 75 microhenries. Okay, and this is for low power applications, for low power charging. So here those switches are being absent, the extra switches were present. Okay, and these are the waveforms which are used. So this is for operating operating the what is that the converter. Okay, by using the zero voltage switching condition. Okay, and here it operates at a resonant frequency of 200 kilohertz, and you can see the efficiency as 98.2%. Here you can see the voltage is 400 volts per division. Okay, and the current, you can see the current, it is sinusoidal in nature. Then here you are operating it below the resonant frequency, and as I told earlier, it is 98.2% here, so it has reduced to 97.7. So this is the charging condition of the battery. Okay, and further, so this here you can see the current value. Okay, so here is sinusoidal, and here it is out of the this one, and in this condition we are implementing the hard switching, and the losses are increased and efficiency is affected. Then we are coming to the concept of wireless charger. So wireless charger, this concept is coming from Tesla, that is wireless power transmission. So it consists of two electrical pads. One pad is attached to the vehicle, and another pad is just installed on our roads. Okay, so what happens from here, we are giving the input AC supply, and by using what is that rectifier, okay, we are converting the AC to DC, and that DC power is being given to the first coil, and due to mutual induction, what happens, the secondary coil is also energized, and from that rectified DC voltage only will be given for charging the battery. So here also we are having the static wireless power transfer and dynamic wireless power transfer. Static wireless power transfer means we are taking the vehicle and we are going to a particular place. There we are halting the vehicle and the vehicle is made to charge. Whereas dynamic wireless power transfer means in a lane consists of full of these resonating coils, and those will be already charged. So automatically when our vehicle is being moved on this lane, it gets charged. So this is how your inductive wireless power transfer is happening in the system, and this is how the capacitive wireless power transfer is happening in the system. So here you are using the inductive coils and you are using the capacitive plates here. So that is the only difference here. Then these are the charging pads. Okay, so it is used for the you are using the ferrite bars, and you are using the aluminium here. So why you are using the ferrite bars? Ferrite bars because losses will be removed and it is completely magnetic in structure. Okay, here you are having the receiver pad and the transmission pad. So I told, as you can see here, this is the transmitting pad and receiver pad. So clearly you can see here. Then this is one road which has been laid in US, where for electric vehicles this is the dynamic way of charging. So in this complete lane you can make the vehicle to run. Okay, and these are the battery swapping techniques what we have See how he is removing the battery and he's putting the old battery. So this will save our time. Okay. Then how to charge the electric vehicle on public networks. So these are the things how publicly we can charge and how we are charging at home. So this is what which is installed at our home. Then how to charge the electric vehicles at work. When we are at work, we will be putting in what is that, in one parking slot. So in the parking slot above we are putting the solar panel, and from that also we can get the power and use to charge the vehicle. Okay, and this is one type of charging station for bus. Okay, and these are the charging infrastructures in India. And now the concept of charging station has come into picture. So this is the charging station what we are seeing. So in cities, charging stations are available with respect to the prescribed area. Then this is the charging station of Tata Power. Okay, and these are the charging connectors what you are using here. Charge demo, this connector is used for fast charging purpose, and CCS charging is also used for fast charging, and this is also the type 2 port. Okay, and these are the connector specification. Okay, so this is GV by T. This is one type of charger, and it is not liquid cooled, but it is used in China and India. Okay, so this CCS is liquid cooled. So that means when we are charging is nothing but importing electrons into the battery and making the electrolyte which is in the condition of water into acid. That means if you are taking a lead acid battery, H2SO4 is the electrolyte what it is used. So when the battery is completely discharged, their H2SO4 won't be there. The electrolyte will become water, H2O. Then what happens? Again, we are introducing the electrons in such a way that the water becomes H2SO. So the power of the electrolyte determines the strength of the battery. So here the connector has a maximum power of 950 volts to 250 amps. That is the maximum power rating, and this connector is having the high power rating of 500 kilowatts. Okay, so it is also used in our country, but it is liquid cooled. It is having some advantages. Then you can see, this is a just example of a Tata Nexon car electric vehicle. Okay, this electric vehicle. Okay, how much price is given it takes for the electric vehicle to charge by using this bottom charging station. So this is called as the kilowatt hour based pricing. Okay, so in this kilowatt hour based pricing, he has taken he is giving for 13 rupees. 13 plus he is taking the fixed starting fees as 15 rupees. So 15 into 33.22 kilowatt hour, that is the energy needed. So when we are doing this, you are getting the 30.2 kilowatt hour plus we are removing the 10% losses. It is 33.22 kilowatt hour. Okay, so that is the pricing. Then pricing of this Magenta Power. This is also one of the charging station. Okay, so it is also using the kilowatt hour based pricing. So it is charging 20 rupees per kilowatt hour. So we need 33.22 kilowatt hour. So when multiplying, it becomes 30.2 kilowatt hour plus 10% of loss, which is 33.22 kilowatt hour. So the pricing is differing with respect to the company. Then Tata Power, it is 18 rupees. Here we are not having any fixed pricing, extra pricing. So it is only the cheapest. Okay, so 597 rupees it takes for completely charging the vehicle. Then another type of pricing is the charged mode pricing. That is a subscription based pricing. Okay, so in the subscription based pricing, you are having different plans: green plan, red plan, yellow plan. So in this green plan, the price is 9 rupees 41 paise, and it requires only 312 rupees for the subscription based plan. So this is what your subscription based pricing using the charge mode. Okay, so these are the energy, and this is validity for 28 days. How much price 355 rupees is enough, and charge will be 9.4. So like this for different modes: green, blue, red, and nitro charge. Nitro charge is usually used for bulk charging. So these are the best charging stations which are used for price wise. Okay, so in the price based subscription based pricing, it gives the least amount. So the charge mode. So the charge mode is the company which is using the subscription based pricing. Okay, then these are the government requirements for implementing a charging station. A charging station should contain 3 fast chargers, 2 slow chargers, and transformers. Okay, so you can have the slow chargers of rating DC slow chargers of 15 kilowatt and AC slow chargers of 10 kilowatt. And fast chargers, the cost of the fast chargers are this type of connector. Connector itself it is and a charger. So 7,50,000 and charge demo it is also having the 7,50,000 and type 2 AC charger which is having an output capability of 22 kilowatt that is 1,30,000. So the total cost for the fast charger is 16,30,000. Likewise, the cost of the slow chargers we are taking completely about 3 lakhs 25,000. Then the total cost of the fast chargers and slow chargers is 19 lakhs 55,000. Then for the charging station, the initial cost is we are using the chargers, electrical equipment, the transformers, and other cables and other things. It costs 8 lakhs. Then we are going for the branding. We are putting paint and we are what is that advertising. For that we are taking the 3 lakhs. And total 30 lakhs 55,000 is the initial cost for implementing a charging station in our country. But here I did not include the what is that area required for charging, how much money required for buying that area or for lease. If you take, you can add for some 10 lakhs and some 40 lakhs 55,000 you can initially required for implementing a charging station. Now if you are going for the running cost, you are using a software management tool, okay, which costs some 50,000 per year. Then you are going to hire a technician. Okay, he charges approximately 1 lakh per year. Then a maintenance worker is needed to see the maintenance and everything is going on properly. So for that 1,80,000 per year. So the total running cost is 3,30,000 per year. So the total cost will be 33,85,000. Okay. Then you are going for the energy consumption. So how much energy is being consumed? So as we know, fast chargers and slow chargers have to be implemented. So the CCS type of charger, which 50 into 20,000 units. So it is consuming 1,000 units. Charge demo is consuming 1,000 units, and type 2 is consuming 300. From slow chargers, they consume 300 and 200 units. So total of 2,800 units electricity consumption is being done. So if you calculate the profit margin, taking 2 rupees per unit, so 2 rupees into 2,800 units, so 7,000 into 365 days, so it is 25 lakhs 55,000. So minus the 3 lakhs 30,000, you will get that 22 lakhs 25,000. Then heat loss. During the charging process, heat will be produced. So for that, some losses will be there. So I'm considering 15% loss, and you will be getting 18 lakhs 91,250 as your profit. So, so that is the concept regarding your charging station and the charging schemes required in this. So, can we wind up here, or shall I continue in this vehicle to grid concept?
Still we have another 15 minutes time, sir. If you want, you can continue, sir.
Okay, sir. Okay, then I will continue here.
Yes, thank you.
So here, when we come across the concept of vehicle to grid, actually, this is a very, very interesting concept. Why? Because vehicle, we are not using the vehicle 24 hours a day. We are using the vehicle morning if you are going to office, from 9 to 4 we are working, and after that from 4 we will be bringing our vehicle to our home, and it is in the rest position. And even in Sundays or in weekends, what happens, the vehicle we are not taking out. So this vehicle to grid concept is nothing but from the vehicle battery assembly is there. The stored energy in the battery can be again given to grid. So this can be given by using your bidirectional converter. So by using the bidirectional converter, you can power the vehicle, power the grid from the vehicle. You are having the vehicle to grid, grid to vehicle, okay? So V2G and V2E. Here you can see if 100 EVs, electric vehicles are connected to the grid, up to 1 megawatt of power can be given to the grid. So grid, in grid connected systems, you can use the PV systems, you can use the wind energy conversion systems, and you can use the electrical vehicles also. So the concept of vehicle to grid, this concept was first introduced by Willett Compton of Delaware University. So what it is doing, the initial goal of this vehicle to grid is to provide peak power. Okay, it is used to give the peak power that is in the electric vehicles owners charging the cars in the low load with low electric price and discharge the vehicles in peak load and high energy price. See, if it is like that, morning I will I'm getting power at very cheap rate, so I'm charging the vehicle, and during night time the price of the power is more. At that time I can give the same amount of power to the grid and they can pay some amount of money. So the vehicle's owners will be getting profited. So a properly designed electric vehicle can produce up to 10 kilowatt of power by its average consumption of 10 houses. So each house will consume 2 kilowatt of power. So 10 houses it can power. And here we have to know about the peak loading levels. Okay, so here we are having the valley filling. This valley filling is nothing but charging at night. We are charging the car when it is in idle position, that is during night from 4 to next day morning 9. Okay, that is called as valley filling. And peak shaving. Peak shaving is nothing but sending back the power to the grid when demand is high. So by doing that, for low price, we are it is just like what is that, selling and buying, and we are attaining profit by using our car when it is in idle position. The peak load leveling. So this can enable utilities new ways to provide regulation services, keeping voltage and frequency stable, and provide spinning reserves. Okay, spinning reserves is another one type of concept in which you are storing the energy. So secondary advantage of peak saving include reducing the transmission congestion. It will reduce the transmission congestion, line losses, delay transmission investment, and reduce stressed operation of power system. As I told you, what is the spinning reserve? We'll tell. Spinning reserve. So this is another generating capacity which is additionally used and which can provide power quickly to the grid operator. Okay, so that is within a span of some 10 minutes, it can give the power. Okay, so the electric vehicle normally incur only short periods of generating power, typically 2 to 3 hours. What are the social impacts? Reduction of electricity bills, and especially for citizens and public authorities. See, current bill for once in 2 months it is coming, and while we are paying the bill, we are very much we feel very bad that current bill is coming around 5,000, 10,000 like that. So if you are having an electric vehicle, automatically your current bill will be reduced. That means when the demand is low, at that time price of the power is also low. At that time we will be using that power to charge the battery, and when the demand is more, automatically we can give that power to the grid. Then increase the quality of life by creating local jobs. So if like this vehicle to grid assembly, if we are implementing, we can employ a person and we can see whether everything is correct or not, so that we can improve the jobs in the society. So this is a complete architecture of your vehicle to grid integration. So in this vehicle to grid integration, here you can see this is the complete structure of our vehicle. Okay, so these are the energy sources. Okay, here we are seeing the nuclear, hydro, solar, and wind. From using that, we are taking the respective converters, and we are converting, and we are giving the DC power, and the DC is again converted to AC. So here this is an inverter, and from the inverter, by using a transformer, we are giving to the grid. So we are giving to the household purpose, and from the house, what we are having, we are using the smart metering, and we are drawing the power for charging the vehicle as well as giving the power, that is called as the vehicle to grid power flow. Vehicle to grid power flow, and this is grid to vehicle power flow. And these things we have seen already. What are the things here? What is the onboard and offboard charger and the battery pack and etc. Now we come across the bi-directional converter. Okay, so see, so this is called as the bi-directional converter. So what is the use of this bi-directional converter? Actually, bi-directional converter means here, here you can see two types of converter. One is the normal converter and another one is the isolated converter. Here, initially, first from the grid, the power is taken and that is rectified, and from the rectifier, that DC power is coming and it is made to store in the battery. But what is happening when this same power we can again give to the grid, like here from the battery it is given to the inductor, and from the inductors by the operation of the switches again it is going back to the grid. So that is how you are using the bi-directional converter. So now during the normal condition, so this is the renewable energy grid, okay, the micro grid, okay, and this is the main grid, and this is the load, and load means our users, and this is a bi-directional converter. So when everything is working in normal condition, the battery is being charged here. Okay, now what is happening here, this battery, what it will do when even the voltage, this voltage is greater than the load voltage. Okay, we are supplying the power from here to the load, as well as the battery is being getting charged. Next condition, when this load voltage is greater than the V1. So when load voltage is greater, so this microgrid is not able to supply the sufficient amount of power, then this bidirectional converter will activate, and this battery power will be again given to the grid. So this battery means again we will take here, consider this as our electric vehicle. So this is the V2G, vehicle to grid type of integration. Next, you are having the V1 is equal to 0. That means due to some climatic calamities, our solar is not working, as well as our wind is also not coming. So this one is 0. At that time, the remaining power which is present in our car or the vehicle can be given to the grid, and the grid will supply power here. Then, so this is one type of bidirectional converter, and this is called as a buck boost bidirectional converter. Why? Because we know when we are designing a DC to DC converter, if the inductor is before the switch, then it is called as the boost converter, and if the inductor is there after the switch, then it is called as a buck converter. So here, this here you can see the buck mode of operation where the switch is there, then the inductor comes. Okay, but here when we are going from this side to this side, from this side to this side, it is called as the boost mode. So I am stopping here. Okay, sir, is it okay, sir? Hello.
Yes, sir. Hello.
Okay, sir.
Yes, thank you, sir. Participants, if you have any questions, kindly ask to the resource person directly by unmuting yourself. Sir, I have one question.
Tell me.
Is that wireless chargers, that chargers can be implemented in toll plazas? Because
Yes, sir.
it will take the 10 to 15 minutes, minimum 5 to 10 minutes, they will stay around there by charge this one.
Yes,
So,
sir. Yes, sir.
as the roof panels can be implemented by using solar panels,
Yes, sir. Yes,
it will be useful,
definitely.
right, sir?
Definitely, that is a very good concept, sir. You can give a proposal
Yes,
for
sir.
our DST board, but
Yeah.
here, there we have to use the dynamic type of wireless power transfer system, so that not only the vehicle which is near the toll plaza, at least for around 3 kilometers around the toll plaza. That means inlet and outlet. If you are implementing the dynamic wireless power transfer, then so much of other vehicles can be getting advantages rather than one vehicle getting charged.
Yes, sir. Because for every 100 kilometer, we have one toll plaza in highway. So automatically, there is no need to stop sometime, and we have to charge, and then we have to go like that. So
Yes,
because
yes.
for every 100 kilometers, we charge for 6 kilometers range. Because as per your suggestion, if you are before toll plaza and 3 kilometer after toll plaza means 6 kilometer distance, we will get maximum charging in time itself. So it will
Yes.
be useful, I hope.
Yes, sir. Yes, yes, yes.
Yes, sir.
That
Any other?
we can put as a proposal, sir. DST, if you are writing a proposal, then it can be implemented in real time, and we can get hope for doing that.
Yes, yes, sir. Any other questions from participants?
Sir, can you provide PPT?
Yes, I will provide PPT, sir. After completing this one, I will just mail the PDF. I will convert it to PDF because it is of 55 MB. So I will convert it to PDF and I will send to the concerned sir, Dhruva Kumar sir. Then he will
Yes,
do
sir.
it.
Thank you, sir.
Thank you, sir.
Any questions related to the session? I hope, I think, sir, we don't have any questions because we all are very much about the session, because you have started from the beginning where electrical vehicles concept started. From there, you can just now, you just stopped the thing, now it is doing, right? So hope everyone has got all the knowledge about electrical vehicles, sir. So I hope there are no questions, I think.
Okay,
Yes, I thank to SV Dishore sir for accepting our invitation and participated in our FDP as a resource person and delivered a wonderful session, because they have started from beginning, from starting from the electric vehicles concept, and they are ended as of now. What are the things going on? So we are very happy for the session, sir. And I thank Manikandan sir, special thank to Manikandan sir, because they have given suggested your name because of their unavailability, and you have delivered a wonderful session, sir. We are very happy for you, and I thank wholeheartedly on behalf of our institution and on behalf of all our participants for giving us such a wonderful session for us. We are very happy that in the future also we may get so much of sessions from you in the different FDPs we are going to conduct in the future, sir. So
okay,
thank you,
okay.
sir.
Thank you.
Thank you
Thank
for
you very much, sir.
and thank you for hearing, sir. Thank you, sir. Thank you so much.
Okay, thank you. Thank you.
Yeah. So it's information to participants. All of you can join to the next session and the last session of our FDP by 2:30 p.m. And after the session will be from 2:30 to 4:30. And the last session will be after that, the completion of last session, we have in a valedictory function from 4:30 to 5 p.m. And then we will complete the session. And the test we will give after 6 p.m. and the links will be sent through mail, and also the quizzes link will be shared in WhatsApp group also. So thank you for all your wonderful support, and we will come back at 2:30 p.m. Thank you so much.